All right, welcome world geography students. So this first unit, we're going to condense quite a bit, and as you see right here, what we're looking at essentially is called the 5 themes of geography, and we're going to focus on one theme a day to make sure that we really kind of understand the information and that we're not moving too quickly as we all adjust to this online learning. So just pay attention, make sure that Wednesday, if you have any questions, you come for the remediation day, that we can go over anything you got questions on. And also please make sure that you're paying attention to the review guide that you've been given and that you're staying on top of both your vocab, that you get that submitted to the folder it's supposed to be submitted to, and that you also are looking over your map information as well. So let's get started. So the thing we're looking at today is just basically location. Don't pay attention to numbers 14 through 20. We're not looking at page numbers. We're just focusing on location. And there are 2 basic types of location that you guys are going to be accountable for. Number 1 is called absolute location, also known as mathematical location. And that is very simple. It literally is just using the latitude and longitude coordinates. If you don't see latitude and longitude, then it's not absolute. That typically means that most of the location types that we use are known as relative location, or what's also known as situation. Relative location is how we speak. It's how we give directions. It's how we relate things around us. And so when you look at the definition here, it says it describes a place in comparison to other places around it. So for example, just went and had lunch at Otter's a little bit ago. If we were going to describe Otter's location, there could be a number of different things we could do. Typically, if we were in class, I would let y'all choose, or at least give examples of where Otter's is. But for the purpose of this, we could say things like it's on Dallas Highway. It is near Chili's. It's across the street from Kroger. It's in the Avenues. It's across the street from Okinawa. And anytime we're doing that, we're not describing its location. We're describing the other places around it and where it lies in proximity to that. So pretty much every direction that you're going to give in your life is going to be relative. Very rarely, or if at all, I can't remember a time in my life I've ever said, yeah, we'll find this. It's at 37 degrees latitude and 42 degrees longitude. And when you get to, that's not how it works. Now, we may use our GPS, which uses absolute location, but it's not how we speak. That's not how we give directions to one another. We could be extremely precise, and we could say that Otter's Chicken lies 2.5 miles due west of Hillgrove at the intersection of Dallas Highway and Castile Road in the Avenues, and it's the 5th building down on the right. That's still not absolute. It's still relative into where it is in proximity to Hillgrove. Okay, and so those are your 2 differences in location. As we look at this, and we're not really going to focus on plotting coordinates, but we do need to understand latitude and longitude. Remember that latitude is flat, okay? Latitude is flatitude. So if you follow my cursor here, these lines right here are lines of latitude. And while they run east to west, they actually measure north to south, because look here, 40 north, 30 north, 20 north. What it's showing you is the relationship north or south of the equator. Of these 2, latitude is the one that is naturally occurring and that can actually affect weather. And you all know this, we just don't think about it this way. If you have a high latitude area, 90 degrees north or south of the equator, you're a long ways from the equator, which means it's going to be extremely cold. So latitude has the ability to affect climate. Longitude does not. Longitude, even though these are lines of longitude, they're long. Longitude is long. They go east and west. They're measuring east and west of the prime meridian. Well, it doesn't matter where you go east or west. That doesn't dictate climate. Latitude does. So 2 things that dictate climate, latitude and altitude. How far away am I from the equator, and how high am I in elevation? Because we know the higher up you go, the colder it gets. So longitude does not actually affect climate. Latitude does. And so everybody knows about the equator and the prime meridian. The equator, we know, is a line of latitude. Okay, it cuts the Earth into the northern and the southern hemisphere, and the prime meridian is the line that sits at 180 degrees, sits at 0 degrees, and they have the international date line on their side, cuts the Earth into the eastern and western hemisphere. So technically, we have 4 hemispheres on Earth: the northwestern hemisphere, the northeastern hemisphere, the southeastern hemisphere, and the southwestern hemisphere. So as we look at these, a couple of things we've got to keep in mind is that over the course of this unit and over the course of the year, we're going to look at maps and globes, and these are things you learned, in elementary school. Maps are two-dimensional, globes are three-dimensional. However, something that you haven't learned about is what is called a map projection. A map projection, and I encourage you to go back and click on this link because if I show it to you, there will be no sound on it right now. But a map projection, it says, is a systematic transformation of the latitude and longitudes of locations on the surface of a sphere or an ellipsoid into locations on a plane, yada, yada, yada. Y'all are like, what the heck does that actually mean? A map projection is this. You take a globe and you turn it into a map. Now, here's the thing. If you can imagine taking anything round or any sphere, okay, that there is, let's say it's an orange. Well, if you peel an orange, that peel is a curved surface. It's not going to sit flat. To make it sit flat, you have to press it down, which means you're distorting what the orange actually looks like. So anytime we see a map or a map projection, understand this. That's not actually what the Earth looks like. Every map that you've ever seen in your life is very similar to what the Earth would look like, but it can't be 100% accurate because the Earth is a sphere. It's not flat, okay? Contrary to popular belief of many celebrities out there right now. The Earth is a sphere. Therefore, when you make it a map and you project it, it distorts the image. So, that's really it for today on this very basic theme. One thing I will say to go back and look at projections, the reason it's called a projection is because if you can imagine taking a flashlight, shining it through the globe, and it projecting an image onto the wall, that's why it's called a projection. You're projecting that image onto a flat surface. So because it's a curved surface trying to go flat, it distorts the image. It can make the polar regions look bigger than they are. It can make the equatorial regions look bigger. It just depends on how that light is shining on it. So that's it for today, for the first portion of what we're looking at. And we'll pick back up with place in our next portion of the notes.